So I'm going to go over 3 problems from last week's homework that seem to give people the most issues. Numbers 3 and 4 from the worksheet and number 37 from your workbook. So number 3, notice that they want your answer expressed in simplest form of a plus bi, which is a complex number. Now, when I see that, to me as a problem solver, indicates that we're most likely going to be using the quadratic formula here, and we're going to get some non-real solutions. So if we look at our problem, we can cross multiply. So we have x times x minus 1 and 9 times x minus 3. So if we were to distribute both sides, we end up getting x squared minus x equals 9x minus 27. So it is a quadratic equation, so we're going to set this equal to 0, move everything over to one side. So if I subtract 9x on both sides, like so, we end up getting negative 10x, and I'm going to subtract, or add rather, 27 to both sides. Now, if I look at my equation, I do notice that it is a quadratic, and I know my leading coefficient is positive, so it's opening up. And I also know that my y-intercept is 27. So probably my graph is going to look like this, and notice that we don't have any real solutions. It doesn't hit our x-axis at all. So we're going to use the quadratic formula, and we're going to take our answers and put them in complex form. So our quadratic formula is x is equal to negative b, which is positive 10, plus or minus the square root of b squared minus 4ac, and that's all over 2a. So now if I were to simplify this, I'd first start by looking at my radicand, or my discriminant, to be more specific, since it's the quadratic formula. So that's 10 plus or minus the square root. And if I do 100 minus 4 times 1 times 27, I end up getting negative 8 over 2. Now if we think back to our radical unit, we can simplify the square root of negative 8. I'll do this up here. The square root of negative 8, whenever we see a negative in a square root, that can come out as I. And then I can take square root of 8 and simplify that as well. 8 is 4 times 2, so really it's the square root of 4 times 2. So I can actually pull out the square root of 4, which is 2. So 2 comes out of our radical, and we're left with 2i square root of 2. So back to our answer, we have 10 plus or minus 2i root 2 all over 2, making our final answer 5 plus or minus I square root of 2. For number 4, we are going to find a common denominator, which in this case would be the square root of x plus 11. So if I end up looking at this part right here, if I multiply by the square root of x plus 11, doesn't really look like an x, over the square root of x plus 11, now I have everything that has a denominator of the square root of x plus 11. So if I were to multiply both sides by the square root of x plus 11, I would be left with x minus the square root of x plus 11 equals 1. So since this is now a radical equation, I want to isolate the radical. So I'm going to add square root of x plus 11 to both sides and subtract 1 on both sides. The reason I'm doing that is I just like having my leading coefficient of that radical positive. I could have subtracted this x here and then multiplied by negative 1, or just square right away, All those things would have been fine as well. I guess just in my head I think of adding and subtracting. So on the left side we end up with x minus 1. On the right side, the square root of x plus 11 plus. Not really a plus. Okay, so now we're going to square both sides. Now it's May. We should know that when we're squaring a binomial, we're going to have to double distribute, or sometimes we call it foiling. So if we were to FOIL that out, we'd have x squared minus 2x plus 1. And on the right side, the square and the square root would simplify out, giving me x plus 11. So since we have a quadratic equation, I'm going to move everything to one side, set it equal to 0, and then try to factor, or if we have to, use the quadratic formula. So I'm going to subtract x on both sides and subtract 11 on both sides. Give me minus. Now if I'm factoring this, I'm looking for numbers that multiply to be negative 10, add to be negative 3, and quickly we should realize that this factors to be x minus 5, x plus 2, so we get solutions of 5 and negative 2. Now before we move on, we do want to double check our solutions. Easy way to do that is to plug back in. So if we go back to our original equation, if we can clean this up a bit, if I were to plug in 5, I end up having 5 over the square root of 16 minus 1 equals 1 over the square root of 16. So we have 5 over 4 minus 1 equals 1/4, which checks out. So 5 is a solution. If I plug in negative 2, we have negative 2 over the square root of negative 2 plus 11 is 9, minus 1 equals 1 over the square root of 9. Now if I take a look at what's happening, I can very easily evaluate this, but I've noticed that this side is a negative number. A negative minus 1 is still going to be negative, and this side is going to be a positive number. So there's no way that the left side is going to equal the right side, so negative 2 would be an extraneous solution. So our only solution here is 5. Last problem I wanted to go over was number 37 in your textbook. If we notice what's going on, we have a rational expression in a numerator and a rational expression in the denominator. So what I would recommend is taking these piece by piece. I would simplify this first and this, and see if we can simplify the entire left side of the equation after we do that. So if I look in my numerator, I'd have a common denominator of x squared. So I'd have multiplied by x squared, I'd multiply this one by an x, that one would stay. So what I have here is x squared plus 9x plus 20 over x squared. And at this point, when you see a trinomial, you guys probably should think about factoring if you can, and this one we can. It's going to be x plus 5, x plus 4. So that's what our numerator on our left side of the equation is. My denominator, I'd have a common denominator of, again, x squared. So I'd multiply this by x squared, and that's should be a minus, not a plus. 25. So we end up having x squared minus 25 over x squared. Now we can factor the numerator again. That's a difference of common squares. So what I have here is this fraction, or this rational expression rather, over the blue one. Now when we have a rational expression being divided by a rational expression, we can simplify that hopefully by multiplying by the reciprocal of whatever we're dividing by. So to do that, we have x plus 5, x plus 4 over x squared. And instead of dividing by what I had in blue, we're going to multiply by the reciprocal. And see if things will start to simplify, which does look like it will. The x squareds can go away, and it looks like I have an x plus 5s that can go away. So what I have left on my left side of the equation, I have an x plus 4 in my numerator and an x minus 5 in my denominator. So the left side of the equation, x plus 4 over x minus 5 equals the right side, x plus 4, x minus 5. So what we have here is we have the left side equaling the right side. So normally that would mean our solution is all real numbers. However, because this is a rational expression, there are some numbers that could potentially make our denominator 0, which would be a domain error. So all numbers can be plugged into this equation and make it a true statement, except we know that x cannot be 0, because if it's 0, either the red expression or the blue expression would be would have a domain error, so it cannot be 0. And we know that if we take a look right here, if x was either 5 or negative 5, then this entire expression would be a domain error. It would have a domain error as well. So it cannot be plus or minus 5. So that would be our solution.